there are a lot of things about the universe that I find it almost impossible to imagine. Well, actually impossible to imagine. One, just the size and scale of it.
I've experienced an existential crisis as a result of all I've ever learned about physics, science, the universe, and space. The cosmos is full of amazing beauty and difficult problems, and it has long been a source of mystery and fascination. For millennia, people have been fascinated by the question, what is out there, and how does it affect our perception of life and existence? Have you ever pondered what horrifying locations might be found outside of the well-known boundaries of Earth? This very subject was recently studied by renowned physicist Brian Cox, who provided insight into some of the most hostile and concerning settings in our solar system. What does he disclose, however, about these unique places and their consequences for humanity? Come along with us today as we explore Brian Cox's observations about the most horrifying locations in the universe and see what makes these far-off worlds so both intriguing and terrible. It's a lovely thought that the mountains of Venus are covered in what amounts to silver snow. Thus, it demonstrates the universality of the laws of chemistry that we observe, experience, and study on Earth. However, when you subject them to other circumstances, the results are drastically different. Even in laboratories on Earth, we are unable to replicate some of the circumstances found in the solar system, such as extremes of temperature and pressure that are extremely difficult or impossible to replicate here, not to mention unusual chemical composition. Thus, the solar system can be used as a chemical set. Let's explore some of the most horrifying locations in our universe before learning what Brian Cox has to say. First up, the magnificent attractant. All of the forces that currently hold everything you know and love together will be defeated. Because the universe's expansion is now showing up locally rather than on a much greater scale, the galaxies will no longer be able to support themselves. Consequently, galaxies begin to stretch apart. After that, the planets that orbit the stars begin to separate. After that, the molecules begin to disintegrate. The atoms themselves come next. This stretching, known as the Planck length, then approaches the very pixels that make up the fabric of space and time in the limit. Imagine yourself encircled by stars and galaxies while floating across the immense void of space when all of a sudden you are pulled strongly by gravity. Welcome to the Great Attractor, an invisible force located at the center of our Milky Way galaxy's home region, the Laniakea supercluster. Over great distances, galaxies are greatly influenced by the Great Attractor, a gravitational anomaly that causes them to approach it at amazing speeds. The Great Attractor's enigmatic character is what makes it so unnerving. This force's precise nature is still unknown despite its strong gravitational effects. Although part of it is out of our line of sight, scientists think it might represent a large concentration of galaxies and dark matter. Therefore, it is challenging for astronomers to directly analyze the source of this gravitational force because it is mainly hidden by a thick veil of gas and dust. Because of this, the Great Attractor is a source of fascination and terror in addition to being a strong force. The Great Attractor's size is astounding now. It is thought to be drawing our Milky Way galaxy and innumerable others toward it at a pace of roughly 600 kilometers per second. It is situated between 150 and 250 million light-years from Earth. Imagine this now, galaxies rushing through space, all attracted to an invisible force they are unable to understand. We are left wondering what will happen to our galaxy and the innumerable others that are impacted by this cosmic tug-of-war. When we get to the Great Attractor, what happens? Its powerful gravitational pull will either tear us apart or cause us to change into something else. We could experience awe as we look up at the night sky. However, the Great Attractor, a reminder of the powerful and horrifying forces at work, lurks in the depths of the universe. It acts as a sobering reminder of our position in the universe, enmeshed in a web of gravitational forces and drawing closer and closer to an inexplicable force that we can hardly comprehend. The Whirlpool Galaxy comes in second. Let's move on to the M51, also known as the Whirlpool Galaxy, which is roughly 23 million light-years from Earth. This galaxy could seem like a beautiful spiral of color and light at first glance. However, beneath its lovely exterior is a terrifying world. One of the best illustrations of the violent and chaotic processes that control the cosmos is the Whirlpool Galaxy. The Whirlpool Galaxy's relationship with NGC 5195, a tiny companion galaxy, is among its most unnerving features. The cosmic dance between these two galaxies has significant ramifications. NGC 5195 disrupts the bigger galaxy's spiral structure as it moves through the whirlpool's outer regions, causing waves of star creation to follow. An atmosphere where new stars are formed quickly is produced by this interaction. However, it also causes huge stars to violently die in supernova explosions. Even by themselves, these supernovae are a terrible sight. A huge star collapses under gravity when its nuclear fuel runs out since it is unable to sustain its own weight. An enormous amount of energy is released as a result of this collapse, momentarily outshining entire galaxies. Additionally, these explosions have the ability to create gamma-ray bursts, which are among the universe's most potent and energetic phenomena, by releasing heavy components into space. Earth could be devastated by a gamma-ray burst in our galaxy, which could wipe out all life as we know it. Furthermore, a supermassive black hole is located at the center of the Whirlpool Galaxy. Among the universe's most mysterious and terrible objects are black holes. There are areas of space where light cannot escape due to the extreme gravity. This black hole's existence indicates that the galaxy is undergoing tremendous forces that have the power to destroy anything that approaches it too closely. It acts as a reminder of how violent and erratic the universe is. The Whirlpool Galaxy's immense size is even more terrifying. It has hundreds of billions of stars, many of which will unavoidably die in catastrophic explosions, and has a diameter of roughly 76,000 light-years. The galaxy's splendor conceals a world of mayhem, devastation, and the constant danger of supernovae and black holes. The Boötes void is the third number. Let's now investigate the Boötes emptiness, a massive cosmic emptiness situated within the Boötes constellation. With a diameter of over 330 million light-years, the Boötes void was discovered in 1981 and is one of the biggest voids in the cosmos. To put this into perspective, we would be surrounded by an almost unfathomable emptiness if our Milky Way galaxy were situated inside the Boötes void. There should be hundreds of galaxies in this enormous expanse of space, but there are only a few dozen. As we consider the enormous expanses of space, the Boötes void's emptiness and sheer size evoke existential dread. It can be unnerving to consider such a vast region free of celestial bodies. It serves as a sobering reminder of our potential loneliness and insignificance in the universe's larger scheme. The Boötes void and other cosmic voids are thought to be created by the gravitational interactions of galaxies, which pull them toward one another and leave behind large empty areas. Research on the exact processes underlying the creation of these holes is still underway, though. The Boötes void's relative age contributes to its unsettling atmosphere. The fact that the void has remained mostly unaltered for billions of years indicates that it has been a barren area of space for a substantial chunk of cosmic history. Imagine finding yourself adrift in an area devoid of the stars and galaxies you are accustomed to seeing. You would become intensely aware of your loneliness in an otherwise bustling universe, and the solitude and emptiness would be overpowering. Furthermore, the Boötes void casts doubt on our conception of the structure of the universe. It calls into doubt the nature of dark energy, that enigmatic component that appears to be speeding up the universe's expansion, as well as the dispersion of matter. The existence of the vacuum raises questions about the numerous mysteries that remain unsolved and suggests the complexity and unpredictable nature of the universe. The cosmic microwave background radiation is number 4. Imagine now that you are in a large, dark room with nothing in sight, but the air is filled with a faint, lingering hum. Experiencing the cosmic microwave background radiation, CMBR, the remnants of the Big Bang that formed our universe some 13.8 billion years ago, is similar to this in some ways. The CMBR, a spectral relic of the universe's flaming beginnings, permeates the universe. Examining it reveals a world of wonder and fear. In essence, the CMBR is the thermal radiation that permeates the universe and is a holdover from the early, hot, dense condition of the universe. This radiation was produced when the cosmos cooled and expanded, giving us a glimpse into the immediate aftermath of the Big Bang. It's as though you could hear the echoes of a massive explosion that gave birth to all we know, the whispers of the universe's early days. The consistency of the CMBR across the sky is what makes it so alarming. It demonstrates both the basic randomness that defines cosmic occurrences and the amazing uniformity of the universe's early state. We can follow the earliest stages of the formation of galaxies, stars, and planets by examining the minute temperature variations found in the CMBR. The chaos that exists in the universe today, where black holes, supernovae, and other cosmic horrors await, is concealed by this regularity. Significant queries concerning the destiny of our universe are also raised by the CMBR. The CMBR cools and stretches as the cosmos expands, pushing in the direction of longer wavelengths. A terrifying realization, a potential end to the heat death, occurs as a result of our cosmos moving toward a condition of lower temperatures and sparser energy. In this scenario, galaxies separate, stars burn out, and the cosmos turns into a pitch-black, lifeless emptiness. Nevertheless, the CMBR is crucial to our comprehension of the universe in spite of its eerie connotations. Numerous significant cosmological discoveries, such as the validation of the Big Bang Theory and the existence of dark energy, have been made possible by it. The CMBR reminds us that there are remnants of our past and paths to the future even in the midst of darkness. It challenges us to face the unsettling reality of our cosmic frailty in the face of the huge, uncaring cosmos. Number 5. A black hole's event horizon. A black hole's event horizon encircles it and, in a way, marks the separation between the black hole's interior and the outside world. You cannot escape the black hole's gravitational pull if you cross this barrier and enter the inside of this sphere, even if you are able to travel as quickly as light. However, the idea that the event horizon is a location in space where time pauses when viewed from the outside is another description of the event horizon that has perplexed people throughout the history of black hole study. Additionally, that's a direct Einstein's theory of relativity was predicted. However, from the outside, there remains a major issue that has yet to be resolved. What is at the core of a black hole? Let's now explore the frightful world of black holes, more especially the event horizon, the point of no return that encircles the cosmic giants. Imagine gazing into an endless abyss from which not even light can emerge. This is what a black hole is all about, and the event horizon is the point at which gravity gets so strong that nothing can escape it, not even light. When enormous stars toward the end of their life cycles collapse under their own gravity, black holes are created. An event horizon forms around the singularity, the point of infinite density in the center, as a result of the core imploding. The gravitational attraction becomes stronger as you get closer to this limit, distorting both space and time. Time as you know it starts acting oddly. An observer at a safe distance would see your approach take a lifetime, but as you get closer to the event horizon, it slows down considerably. A troubling conundrum is now created by this odd result of time dilation. Your destiny is entangled with an unavoidable gravitational prison. The event horizon is a dark cloak that conceals a number of horrifying mysteries. It is more than just a cosmic barrier. When an object crosses the event horizon, what happens to it? Their information appears to be lost to our universe, which raises troubling questions about the nature of reality and information conservation. Known as the black hole information paradox, this puzzle has generated intense discussions among physicists. The potential for black holes to eat up everything in their path, however, is arguably their most alarming feature. They have the ability to attract gas clouds, planets, and stars. An accretion disk is created as matter spirals toward the black hole, heating up and radiating intensely. Strong energy jets that blast out into space at almost the speed of light can be produced by this process, wreaking havoc in the cosmic vicinity. Consider yourself aboard a spacecraft that is too near a black hole. The strange effects of gravitational lensing, which causes the light from stars behind the black hole to become warped and distorted, would be visible as you got closer to the event horizon. The cosmos would seem like a stunning yet terrifying tapestry of hues and forms. However, All hope is lost the instant you step through the door. You would be drawn into the singularity, where the rules of physics as we know them would cease to apply, by the black hole's tremendous gravitational force. Sixth, the foundations of creation. Let's now investigate the spooky splendor of the pillars of creation, which are situated roughly 7,000 light-years from Earth in the Eagle Nebula. The pillars of creation may appear to be a tranquil and majestic scene at first glance, a magnificent expanse of tall columns of gas and dust, lit by the light of neighboring stars. But beneath this alluring surface is a terrifying reality about the harshness of cosmic creation and the life cycle of stars. Standing 4 to 5 light-years tall, the pillars are enormous formations made mostly of dust and hydrogen gas. These massive formations are constantly changing due to the intense winds and radiation from the nearby freshly born stars. It may be unnerving to realize that these lovely pillars are also the foreboders of catastrophe as you look at this mystical scene. The pillars' ultimate downfall is sparked by the same stars that give them life and brightness. Massive stars inside the pillars will burst into violent supernovae as their nuclear fuel runs out, releasing the gas and dust into space. Although this cycle of creation and destruction is a basic feature of the cosmos, it also brings to light a horrifying reality. Every exquisite creation contains the seeds of its own demise. The fleeting nature of life in the universe is demonstrated by the pillars of creation. Furthermore, there are risks associated with the star-forming process inside the pillars. New star formation may result from shock waves produced by the strong radiation and stellar winds compressing neighboring gas clouds. A hostile and tumultuous environment can result from these same forces, too, as they can also remove the material required for stars to form. We are reminded that beauty frequently conceals danger by the chaotic and uncertain atmosphere created by the interaction of creation and destruction. The famous lecturer and physicist Brian Cox frequently expresses his wonder and fear of the universe. With awe and existential anxiety, he recently finished a series called Solar System in which he examined the most horrifying locations in our cosmic neighborhood. He takes us on a voyage through the unnerving truths of our solar system, exposing the terrifying qualities of these far-off worlds as well as their breathtaking beauty. Cox starts off by considering how unnerving space is and how his knowledge of physics and the cosmos has caused him to experience a severe existential crisis. In a cosmos where complex life forms may be extremely uncommon, he talks of the terror of being alone. This idea keeps him up at night and makes him yearn for proof that there is life somewhere else because it could lessen the burden of being so alone. The idea that we might be the only planet with complex life in the Milky Way galaxy appears to be at the heart of our existence. Cox says Venus is especially terrible when compared to the other uninhabitable planets. He envisions the terrifying end of anyone trying to land there, squashed and dissolved in sulfuric acid, with temperatures reaching 450 degrees Celsius and an atmosphere that crushes down with 90 times the pressure of Earth. Venus is shown as a horrible place where survival is not just unlikely but impossible due to these harsh conditions. Curiosity and caution are evoked by Cox's exploration of Mars. Although there may not be an imminent threat when standing on its surface, he observes that the stark reality of the planet is nonetheless intimidating. Despite being easier to handle than Venus, Mars nevertheless poses risks due to its desert terrain and extremely cold temperatures. The possibility of extinct life and the continuous hunt for indications of habitability are what make Mars so alluring. As one moves outward, Cox brings up Mercury, where the climate is harsh yet manageable in comparison to its neighbors. On its surface, the sun burns ferociously, resulting in a barren landscape with sharp variations in temperature from day to night. He acknowledges the planet's gloomy beauty in the midst of its ruin and displays a kind macabre fascination with it. Cox imagines himself being on Triton, Neptune's largest moon, which stands in sharp contrast to these terrifying scenery. Here, he envisions the frozen landscape with bizarre outbursts that extend into the sky. Even the most beautiful locations in our solar system have their own hazards, he admits, even though it could be a strange experience, and stresses the need for protective gear. Cox highlights throughout the series that the stories are based on the most recent scientific findings. Our knowledge of the solar system is being reshaped by new data as technology develops. He remembers shooting in a number of isolated places, such as Alaska's Denali Glacier, where breathtaking views were produced in spite of the logistical difficulties in getting there. His tales relate to the discoveries made in the cosmos while highlighting the excitement of visiting the most breathtaking locations on Earth. The possibility that metallic snow covers Venus highlands is among the series' most exciting discoveries. This astounding idea demonstrates how, in extreme circumstances, the principles of chemistry can produce surprising outcomes. Although we are aware of these principles on Earth, Cox points out that they can appear in drastically different ways in other parts of our solar system. Utilizing the solar system as a chemistry set illustrates the enormous potential for learning and the unsolved mysteries. Make sure to press the bell and subscribe if you like this adventure and would like to learn more about the universe so you don't miss the next in-depth exploration. As always, thank you for watching, and keep looking up.